space band. All around you is the sound of laughter. Joyous people celebrate a life so grand. Hey, mister, read that fairy tale again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. A gentle breeze blows across the ocean, sending waves that crash upon the sand. Hey, mister, did you watch Slow Down again? There is time for you to smell the flowers, even though the thorns get in the way. Hey, mister, what's your theory for today? Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day.
Oh, come on outside, ladies and gentlemen, boys and girls. What you're about to see is out of this world. Step right up now, don't be shy, because we're about to show you how cars can fly.
Here's a tale of a suburban housewife who dares to fight with the icon of his day, and she finds her own miracle on the way. I said, hey now, life's a joy. You gotta try your best and give your all, and when the facts don't fit the theory, change the facts again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. It's a beautiful day.
5, 4, 3, 2, 1. Silence. Good morning, good evening, good afternoon, wherever you are in the world. You have reached Saturday Science Chats. Yeah, I've been gone for a couple of weeks, but it's good to take a few weeks off. It is summer here in the Northern Hemisphere. I know I lived in Brazil for 3 years, so I know that, hey, you can't just say it's summer everywhere around the world. But it was great to take a few weeks off, and I'm back. It's really great. We've got a great show for you today, and we got a lot of new announcements, a lot of things happening in our group in the world of critical thinkers. So we want to start there, and let me get that up and running for us. Take a look. Again, you have reached the Saturday Science Chats, and that is sponsored by the John Chappell Natural Philosophy Society and Dissident Science. I know we're coming up to 900 subscribers, so don't forget to like and subscribe this video. Really important so we get the word out, because there is nothing like this on the internet anywhere. Everyone says that, but this is for certain. You're not going to find this certainly at universities or even with science evangelists around the world. But anyways, you have reached us, and today, of course, you don't want to miss it. One of my favorite human beings to talk to. I met him in Vancouver, Canada. Met him during our conference there, and he said, you should talk to this guy. He's interesting. I've heard that all so many times, and it turns out to be usually not true, but this guy turned out to be super fascinating. And he's got his second edition book just came out. Notfinity Process, Matter in Motion, second edition. Lots of new stuff in it, and so you can get it. But we'll be talking about that. But don't go away. But of course, I want to thank you. There I am. Yeah, I got my natural haircut. Haircut and my natural color. Yeah, the top's still colored, but it's going to go white natural. Yep, that's me. New look for the year. But I want to thank everybody for their support, for you watching this channel, for you coming in, taking a chance, listening to things from critical thinkers, great minds who are outside the mainstream, who are afraid to say, the Big Bang has got problems, relativity's got problems, plate tectonic's got problems, and in fact, we have people who are been thinking about that for quite a long time and who want to give us new ideas and new directions. But without your support, without you subscribing, without you being a member of organization, without you watching these videos and doing a likes up, remember to put a likes up on this. And of course, these things wouldn't happen without you. Of course, where critical thinkers meet. We're the John Chappell Natural Philosophy Society. Of course, Dissident Science. I've hijacked our Dissident Science channel as well, and all my subscribers to follow this journey of interviews, a different format we have. And we are a forum for study, debate, and presentation of serious scientific ideas, theories, philosophies, experiments. So we are like any other scientific organization, almost, but we are above all an organization that promotes critical thinking without malice. So if you don't think you like the way things are going in the world of science, and you have some critical ideas, critical thinking and ideas, and you want to get those out there, we do above all support and promote critical thinking. We are also support serious work outside the mainstream. We also provide a forum and debate like we do today. We also have a conference coming up, so you want to check that out, on modern topics in physics, cosmology, philosophy, mathematics, and other topics. And we do provide a forum for presenting serious papers. We do have our proceedings we are publishing every year, and we are accepting papers already for the proceedings. And we got lots of people. Hey, I've got one at least. My dad's got one. We've got Jeff E. putting one in there. Hopefully we'll get George to get right. He's a prolific thinker and writer, so it'd be great to have something from him. But if you have something you want to get out to the world, can't get it published anywhere, then we will publish it in our proceedings, and you will be published at that point. And believe me, we've got some pretty amazing people who have published throughout the last 20-some years of this organization. So, and we also are run and controlled entirely by our members. And who we are, we're open to challenging mainstream science. That's why you aren't going to see anything like this on the internet. We allow and encourage competing ideas or models. If you notice that I'll bring people on here that have conflicting ideas of how the universe works, but they're great models. They all deserve attention, and who's to say who's not right, who's right or wrong? And so that is something that we do. We encourage competing ideas. We also follow the scientific method. I know it's so stupid to have to say this, but yeah, people think that if you make a new model for the universe that, oh yeah, you just throw the scientific method out. And of course, you can't, your theory, we have to prove by experiment, et cetera, et cetera, et cetera. It's just, yes, we have to follow everything that everybody in science has to follow. We're no different than mainstream science, except for one great idea, which is there are no theories that are correct. You can't prove anything. We basically, as my father says, which I think is a great saying, we try to be less wrong than the generation before us. So, and we can consider an idea without accepting it. It's very important. The way you're going to get something out of this channel, out of the Dissident Science channel or CMPS channel and the speakers, is to understand that, in fact, you need to be able to sit back and say, okay, well, let's see what this person has to say. And that's what we do, and that's what we have. And we give voice to the voiceless, because people oftentimes have amazing work, like Dr. James Maxwell, who should be the world's premier geologist, giving lectures for expensive fees all across the planet, the expanding planet, and he's not. It's just so sad that we're in a part of history in many ways, including science, where the great ideas that I'm sure 100 years from now will be mainstream, the people themselves are not benefiting in the ability, not financially, but in the ability of being listened to and being able to spur on so much great work. I mean, Dr. James Maxwell is a good idea, a good reason. can't speak this morning, can't think this morning, is a good example of that. This is where mainstream advances, always, always, always. It's outside of course, mainstream that advances. What we are not, we don't have a specific point of view. I often use Electric Universe as an example, which is a great organization. I applaud them, support them 100%. It's just that they are more specifically point of view of that the universe is electric, which is an interesting point of view. There are certainly a lot of things out there, and they have a lot of great work, in my opinion, that is much more correct than the mainstream. Of course, we're not also a general science organization, so we don't get out there and just say, oh, we're going to make you understand how a catapult works. It just doesn't, or a laser. So we're also not a new age kind of thing where we're talk about, the whole lifestyle of human beings and their culture and stuff. We are not conspiracy UFO. We're not into that, because why? We need to stick to foundational science, and let's just figure out like gravity fields, magnetism, tectonics, all that kind of stuff. Let's try to get that one before we get off on, on tangents. We do have great websites. Our website for those people who are not super into the real technical side of physics and cosmology, go to beyondmainstream.org. It used to be called Science Woke. We changed it because of the name, because people hijacked that name. I don't think people beyond mainstream is going to get hijacked. So that was a great suggestion. I want to thank Nick Percival for spearheading our committee and people to come up with a new name. We did. We rebranded. Looks great. We get a lot of reads on there. I think we're coming up to 100,000 views on our pages there, so that's great. Naturalphilosophy.org, of course, is our critical thinking community. It is sort of like a Facebook kind of thing where you can get on there, join groups, discuss, debate things. You can see that. You can post things there. Encourage people to join us. And of course, we have our Wikipedia, which is in fact very loaded. People go, oh, you got some, no, we got over 10,000 pages. So take a look at that. That's a great place where we have cataloged an immense amount of information on the dissident world, probably more than anybody out there. So we do have memberships, and I do want to thank a couple of new members. I won't take them by name because they already have been contributors. They actually have been what I call patrons of our site, but a couple of the patrons actually joined in on monthly in this case. And one person came in at $25 a month, another person came in at $5 a month, but those people have been donating as well. We do have annual memberships, $35 all the way up, and any just donations once in a while, people will feel generous and give us some money from $5 on up, and it's greatly appreciated, everybody's support. Of course, these some of the patrons patrons, some Patreon, it's the website everybody uses. No, patrons, Nick Percival, who gave a very generous donation, Dr. Cynthia Whitney, who always gives us a generous donation, Ramsey as well, and other people who have donated throughout the years. I've been putting people's names up there for a while, but put the main names. And yes, folks, we are actually starting to have our CMPS 2021 virtual conference. It's going to call Beyond Mainstream. I was trying to come up. It's like we got a t-shirt. We're going to have I got all that. I'll show you. It looks like I'm looking in the October time frame. I am not decided on whether or not we're going to go a number of days in a row. I'm thinking about doing that because the problem with us doing it like just weekend after weekend or weekend, it sort of doesn't get a concentration. It doesn't really feel like a conference. So I'm really thinking about doing pretty much the same way we did from Wednesday to actually Sunday in this case, or Thursday to Sunday. And we will basically do it all day because we have people around the world. If we do it only in the evening in the United States, everybody in Europe's out, and that's not good. So what I'm really thinking about doing is we're going to have either Wednesday or Thursday through Sunday, because then, of course, the weekend people have their time off. So most likely I'm thinking, I'm just thinking at the top of my head right now, probably Thursday, Friday, Saturday, and Sunday in October. I've got some dates sort of picked out, and we'll do them all day those days. And, of course, people will be able to watch when they can. We're going to have it so that people aren't going to be giving their talks. We're going to have it be able to, all the talks will be pre-recorded and available so that people can watch them. And then we're going to have Zoom meetings to discuss them. So the person's going to come on, they can say a few words, and then we'll just let discussion. So trying to get with the Zoom the ability for us to sort of talk face to face, that kind of thing. So again, probably October time frame, probably Thursday through Sunday, the entire day. So we'll be able to catch people from around the world, both in Australia, the United States, of course, because if you're in the United States, you're going to be the best off, and then Europe also will be able to participate. So, and yeah, look at that. We got a t-shirt design already. What's going to happen, we're going to make t-shirts and have those available. And we're also going to have, we're going to have our credentials, and those will be available as well. And so when a person signs up to be a speaker, I'm working on the page for paying for all this. They will, if you're a speaker, you'll get a t-shirt. I get a credentials. Those will be sent to you ahead of time. We will mail them to you in the United States. A little bit harder across the pond. So I'm still trying to think about how to do that, because then all of a sudden anything over to Europe is about $50 no matter what you do, just for shipping. So since people aren't flying, I may just have to do that. So, but regardless, that way when people are presenting the idea, they'll be able to wear their t-shirt and their credentials, and also our proceedings. That's not the cover really to the proceedings. It's going to be very similar to that, because that's the similar format we've had. And the proceedings will be all available for everybody to buy ahead of time. And instead of, normally we buy them and people at the conference, you receive all these things at the conference, but we're not going to do that. We're going to make the t-shirts, make the credentials, and then the proceedings will be available. We'll close the book on 2 weeks before, and then you'll be able to buy that from Amazon around the world, from anywhere in the world, and order your own copy so you can then follow along with all the talks and everything. So that's going to be pretty cool. And our publishing is coming along really well, in the sense that we in the CMPS do help people publish. Everybody publishes, of course, on their own, but we like to support them. So they have been very gracious to be able to say, yes, we are in fact an organization that helps publish. So you'll see often our logo and the John Chappell Natural Philosophy Society on it. Sometimes it's not that way, but it's still totally affiliated. And of course, just publish. And since the last talk, we had, it wasn't published, but it is now, and that's Notfinity Matter in Motion. It's supposed to have dashes, I know, but and that's by Geroge Coyne, Consciousness, the Big Bang, and other things, relativity, etc. We'll be talking much more about that. So that is published. You can buy it online right now. And also published is the book Ether, over 400 pages by the pen name Ramsey. And I'll show you how you can go and actually get that for free online. And publishing in August for sure. We are, because we now have a deadline, we have our last editor, all changes. I want to thank everybody for that. And that's coming up. But here we go, is Ether is published. You can go to The Ether by Ramsey, Ramsey, RAMSEY.com. Go there and you can get the table of contents there. You will get the entire book online for free. And the author has asked if you can make some small donation, $5, $10, whatever. He doesn't want it even for himself. He said, please donate that to the CMPS. If you go to naturalphilosophy.org and click on the memberships and donation button at the top, it's a sub menu. You can do that, and you can click the donation. We know it works, all that stuff, because we have people doing donations, and it's greatly appreciated. So that is available for everyone. I'm thinking I'm going to take my father and I will perhaps present this book, because the author is remaining more anonymous, but my father was one of the heavy editors of the book So he worked with them for many years, actually, with the overleaf system, with the same one we use for publishing both our proceedings and our books. Our book was on that. Ramsey's book was on that as well. And then, of course, the Notfinity Process, Notfinity Process, Matter and Motion is available on. And here's the cover. You can see again, there's the John Chappell Philosophy Society, the logos for that. And a very similar cover. If a person's willing for us to do the cover, we're trying to make the cover somewhat similar so that we have a branding across our different authors. And so you can see that. And of course, Principia Mathematica 2, that's coming for sure in August 2021. Gosh, 2021. It's too weird to even say. And this is ours. You can see the similarity in the covers here. This one, of course, will be available on Amazon, both in ebook format and also a book, regular paperback book, all in color, by the way. So I think it's going to be $35, all in cover, over 200 pages. It's really important because one of the preliminary feedbacks we have gotten from people is that it's super fun to read, and people really like the graphics, and that was one of the things we worked very hard on, because this model is really not a mathematical model. It's more of intuitive picture in your mind the real physical things model kind of thing. So that's coming out. And just for everyone to know, whether if you're interested or not, we will have a virtual and in-person book signing and birthday party for my father. It's going to be on August 21st, 2021, from 6 p.m. to 11 p.m. here in Boca Raton, Florida. And you can watch it live on principiamathematica2.com. And you can also, if you want to join in, people who are going to be buying the book for long distance and want us to sign it, we can interact with you at zoom.principiamathematica2.com, and we'll be able to talk to you and sign our book. And of course, this is the second part. This is a poster. I just broke it up into two pieces. Complete Toolkit for Hacking the Physical Universe. There'll be a live book signing. Copies will be available. You can purchase those online right now. If you go to book.principiamathematica2, we are going to have t-shirts and caps available also, and presentation by authors. In fact, I got a little bit of tease on that. And we're going to have live music. I won't give it away because it's a surprise for my dad's birthday, but it's going to be a heck of a birthday party. If you can't make it, you can at least do it virtual. Get your drink of choice out there and toast my dad's birthday and our book coming out. And this is going to be this is actually going to be part of our talk, because many of the people buying the book are not people who even care much about science. They know us, they know we've been working on it. So I am actually putting together a slideshow for somebody who doesn't even know science much. Probably couldn't even tell you maybe Newton was the guy who came up with the equation for gravity. So no criticisms, but the particle model for dummies. And of course, you see our famous, what I call movement classification from the particle model. So we'll be doing that. And play coming attractions. Good thing I put these in here. I would just always forget this, huh? There was coming attractions. Of course, we have Stephen Bryant lining up here. I've talked so much about him. I won't talk to him much, but get his book, Disruptive, Rewriting the Rules of Physics. The demise of relativity. Again, relativity is the most disputed theory ever in physics. There's not been any theory that's had 10,000 papers, people, efforts, videos, books, written about how the theory's wrong. Just haven't happened. So he's not going to talk about it. And of course, we have the extinction shift theory with James Verbelli. I'm going to try to talk with him about coming on and talking about his work. It's quite extensive. Dr. Alexander Unsker has agreed to talk. I'm not sure I'm going to be able to bring him on a Saturday, but I think what I'm planning to do is maybe have him and I sit down and do some sessions and record it, and then play those for like 15, 20 minutes, our conversations, and then open up for discussion here. So we're looking to do that. And of course, we will, once our book gets out there, we will be coming on board and talking about the particle model, which I predict that most people in our organization won't really. They're more etherists, so I think it's more for people who are looking for physicality and who aren't already don't have their own theory and stuff. But I think we got quite a lot of interest around the world, and that's really good, because giving physicality to the real universe, because everybody talks about the fields. Every model you come up to talk with is, oh, it's got an electric field, it's got Coulomb's field, and it's got a magnetic field, and then they never tell you what that is. In our model, we tell you what everything is, right or wrong. So play today's bumper, and I will do that. Yes, today we're going to be talking with Geroge Coyne. I made this particular, I did talk with him because we talked about his book before, so again, it's a second edition, so there's a good portion of it that's already been covered, even in our talk before with George. But I said, let's this time, and we got another talk with him too. He talks about relativity as well. But today we're going to talk about the Big Bang, big problems with the Big Bang. Of course, again, you can get his book. Geroge Coyne is a Canadian philosopher, science writer, educator, and counselor. In his book, Notfinity Process, Microcosms of Emotion, he critiques relativity theory. Oh, how could you do that? Joking, a little bit sarcastic there. The Copenhagen interpretation of quantum mechanics. Really, quantum mechanics have a problem? I would not have guessed. Not on our show, huh? Big Bang cosmology. Oh, another wonderful theory. And of course, while promoting credible alternative models, come on, George, what are you doing? I mean, this is what science should be doing. You should follow everybody else and blindly follow all these modern theories that have so many problems. So, of course, while promoting critical models that do not contain paradox and contradictions. Imagine that. Oh my gosh. He also writes about the paradigm for consciousness. I love his work on consciousness. Love it, love it, love it. Which does not require anything other than the brain functioning. Again, we talk with him about that. He's got some talks about that. I'm sure we're going to have him back on that. But love that stuff. I love that part of it. And this is a little blurb I sent out in our our email blast. Hey, remember, go to naturalphilosophy.org. At the very top on the right, you can put in your email and you'll get blasts that will tell you about what's coming up on our shows here. Or you can get that, of course, at naturalphilosophy.org. For those who conceive the universe as having always existed in some form, the continual new estimates of how far back the Big Bang happened are not productive. The Big Bang theory has multiple significant problems, such as horizon, flatness, monopole, blah, 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 all talking about it, et cetera, et cetera. John will discuss 66 of these issues that's in his book. Attempting to deal with its problems, supporters shamelessly and frequently he changed the facts to fit the theory. Hey, listen, if you don't watch the incoming or the countdown for this program, watch it. Watch the lyrics. If the facts don't fit the theory, change the facts again. Hey, that's in the music by Michael Ruggieri. So, love that song. Beautiful song. Great composer. And of course, an important feature of this edition's discussion of 5 further serious problems with the Big Bang theory, including research released in April 27th, 2019, on a revised estimate of the universe's age. I always get a kick out of that. They literally go in and tweak it from 13.87 to 13.83. I mean, it's just absolutely absurd. And of course, the universe, blah, 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 and it says that was present less than 400 million years ago. million years after the supposed Big Bang. Oh, that's not good. It can be found in chapter 4. Now, just to give you an idea, I'm not going to discuss these at all, but here are over 60 problems. What you see here is the table of contents in the pages 4. Over 60 problems. So it's almost really much closer to 70 than 60. And we have all these. I decided I would just list them. So there's just a few problems there, but I'm sure we're going to be able to talk about the more relevant ones, the newer ones, but whatever. I'm really going to bring up finally our man of the hour. So step up there. There he is, Geroge Coyne. How are you doing?
Doing good. Good to see you again. Haven't talked to you since September when you interviewed me about consciousness.
Yeah, I mean, I was not conscious of that. I'm sorry, I couldn't resist. But congratulations on your new book. Why don't you tell us first of all about your new book? What makes your new book new? What made you write a second edition? Oops, wait.
On the blurb that you had there, it showed the first name, Microcosms in Motion. Oh, why am I losing you? I'm just seeing myself now.
That's because you're talking.
Oh, okay. So this is Notfinity Process, Matter in Motion. And the blurb that when I was...
Well, no, but I had all the blurbs. There's only maybe one place that had that, but all of the rest had Matter in Motion.
Showing description. But anyways, the first one is no longer available. So if anybody goes to the Amazon, they just got to click on the one that says Matter in Motion, and it's got second edition written on the cover, but it doesn't have it when you see it at the top of the Amazon page. It just says Notfinity Process, Matter in Motion, but that is the second edition, even though it doesn't say it on the top at Amazon. So I spent over 3.5 years, maybe 1,500 or 2,000 hours redoing the first edition. There's so much new information that had come out in the last 4 years. It had to be put into another edition. It's I think that over 60 pages and at least 60 pages of new material, 408 pages. They're extremely concise. Would have been maybe 1,000 pages if it hadn't been so concise. But there's not a wasted word anywhere in that book. Right. So it's written basically to update everything and to make the original one much better. There's no comparison. This is.
What's better about it? What's better do you see?
Well, the amount of editing that's gone into it is probably 1,000 hours of just editing. The amount of new material, the way the material has been presented in every chapter, whether I'm talking about consciousness. I give like an example when I talk about consciousness, I say it equates to brain functioning, and I give the example of if a person is moving forward, you can call that body in motion, or you can call it walking. Regardless of what you call it, it's the same thing. Body in motion does not produce walking. It is synonymous. And the same with brain activity. It does not produce consciousness. It is the same thing, a different word. So I've got far better ways of presenting material to make it clear and easily accessible to everyone. But I've kept the core of that book is still there with a lot of new material. But I think this is revolutionary because for the last 100 years, neurologists, people trying to find out how does the brain produce consciousness? And my whole point there was it doesn't. That activity is what we call consciousness. So in a sense, I go about solving the so-called hard problem of consciousness on that. And the same thing on every other area, including the Big Bang chapter, everything. It's far superior to the first one. And the first one has been withdrawn. It's not even available anymore. I made sure it's not available. This is the only one that's out there.
So it's available on Amazon right now, right?
Oh yes, it's been out there since, and it hit 21 out of 1,200 in the physics category for new releases, and in the consciousness, cognitive psychology, it's been it's staying around 5 out of 313 for new releases in paperback. So it's been good in both areas. In the psychology area and in the physics area. And it's been dominating like a lot of the fields, number one for subcategories for quite a while. So it's doing very well. I'm very pleased with it.
So is it available Canada, obviously where you're from, and the United States?
And if you buy in the States, Amazon apparently doesn't charge any mailing costs if you're having it mailed within the U.S. So it's available for people in Canada. It's better to buy it in Canada because if you buy it from Amazon in the States, they'll charge mailing from the States. So I recommend Canadians buy it in Canada and Americans buy it in Amazon.com.
Is it available in Europe as well?
Yes, and I've had sales in Spain. In June, that I started seeing sales show up in Spain, and it's available around the world at 12 different Amazon nations. Amazon ES, Amazon.com, Amazon.ca, and yeah, so it's widely available.
Okay, so why don't we talk a little bit about the Big Bang? Because the last time I remember we were talking in September that we decided we weren't going to touch that subject at all in the book because we were talking more about consciousness at the time, which is super fascinating. So let's say a person's coming here. We've got people watching right now live. Also, we have a lot of people watching recording. The recorded version? What is it that is? Why is it that people what would you say to a person that says, wait a minute, everybody's telling me how the Big Bang's correct and everything. Right. Why would you say, if I came up to you and said the Big Bang's wrong? Tell me, okay, where would you start? I mean, yeah, you can list lots of things, but where would you start? How could you say it in at least a shorter amount other than 68 different reasons?
Well, for one thing, the Big Bang proponents don't even agree on something very important about which came first, the Big Bang or inflation. Anybody that's been following the whole thing, some of them say that the inflation came first. Others say the Big Bang came first. I mean, if they can't even agree on a point as important as that, I mean, I can't take the theory seriously.
Why don't you explain to the people who don't know what inflation is?
Yeah, well, inflation was invented because the Big Bang model was needing to be adjusted because there was problems with it. So they came up with the idea that right after the Big Bang, there was this period where the universe expanded at maybe 1 billion times the speed of light, which sounds pretty bizarre. And it went from the size of maybe a tiny thing, like maybe the size of a grain of sand, to the size of, I haven't got the exact statistics right here because I'm just speaking with notes, maybe to the size of the solar system or something, or size of a basketball, and then the size of a solar system very quickly, within a fraction of a second. And to me, the thing is silly. So that's what inflation is. But then you got people saying that the inflation came first. The whole thing is such a jumble.
Isn't a part? I think the way I understand it is you have the Big Bang against a size, let's say, of a pea, right? Yeah. Of a pea, and then explodes for whatever reason. It explodes, and then explodes into space. Now, the question, I think one of the problems I always talk about too is I always say, okay, here's the universe. The universe is the size of a pea, and here it is. It's in my fingers. Okay, and then I'd say, okay, what's around it? Where is it? Not universe? And then they say, well, no, time and in space, and it all expanded together. Right. So it seems like the inflation also they talk about this idea that not only is the mass, but the actual time and space. So that the idea that it was in a universe and somewhere, and it was sitting in this infinitely empty universe, they say, no, it's all there. But of course, if it has then you get this problem, if it has a size, and I think that's one of the problems. So the inflation part, don't they also talk about space and time also expanding?
That's how they get around the problem of going faster than the speed of light. They're saying, well, it's not the matter that's expanding; it's the space itself is getting larger, and therefore it's not limited by the Einstein's speed of light of 300,000 kilometers per second, because it's like blowing up a balloon is the analogy they give. The space itself is getting bigger, so the universe isn't expanding into something. It's just space is getting bigger, and the space is containing the whole of the universe. But interesting, the guy that came up with inflation for the last 20 years or so has totally renounced it. He doesn't even agree with his own. He's become one of the biggest critics of it, and yet it's still being promulgated. Well, this is the solution. But the thing is, if you understand ad hocs, Einstein has this too also with Glenn Burkhardt talks about. He's got like there's 7 ad hocs to go with relativity, because ad hocs is when something is when a theory needs an adjustment, an ad hoc is created to make the theory work. The Big Bang's had so many ad hocs that should call it the ad hoc theory. The Big Bang ad hoc theory.
Yeah, no, it's pretty amazing. I mean, the idea that it's sort of like, even with black holes, where you had Stephen Hawking having to eventually step back from things, because what happens, these things in science seem to take a life of their own. I mean, I think the word Big Bang is such a great marketing word. It's such a powerful word in itself that people just want to hold on to it. Just like Carmen Miranda, you put fruit on your head, dance around your Carmen Miranda Brazilian. It seems that the Big Bang word itself has become bigger than what it really is. And you said that people are starting around. Is mainstream at all starting to show cracks with the Big Bang or not?
I don't think so. I think the hardcore proponents of it are going to go down and are going to stick with it no matter what it seems. I mean, I showed 66 proofs, any one of which can falsify it, and yet it stands. And you take Einstein at one point saying that if you've got one proof to falsify a theory, the theory's gone. I mean, how many are needed to falsify a theory? I mean, solid proofs. This thing, the most recent one, by the way, is this giant arc of galaxies, which is 3.3 billion light years across, which, according to the Big Bang theory, should not exist because it blows away the idea of the cosmological principle, of homogeneity and isotropy. Completely destroys the cosmological principle. Without the cosmological principle, the Big Bang theory is history. And yet, all the mainstream news outlets saying, well, this thing shouldn't exist. Well, no, the Big Bang theory shouldn't exist.
Right.
This structure shouldn't exist. It exists.
Right.
Throw out your theory because it proves the cosmological principle. Let me just explain that cosmological principle. It's like when you get on a large enough scale, the universe is supposedly homogeneous, in all directions, and has isotropy. But they keep having to increase how large the scale has to be, because no matter how large the scale gets, it isn't. And that's what this great arc of galaxies is showing, 3.3 billion light years across. Before that, the Boss Great Wall, which is on the cover of my book, was the biggest structure ever found. This is about 4 times bigger.
So this is recent stuff.
Destroys the Big Bang theory.
Tell us about because this is recent, right? Why don't you explain again to people who aren't familiar? Explain first of all what they found without the Big Bang. What they found.
I have it right on my screen here. If you want me to just read it, here. A team of scientists has found a gigantic structure in space called the Giant Arc. That's way too big to exist based on what we thought we knew about the universe, i.e., the Big Bang theory. The Giant Arc is a massive collection of galaxies, galactic structures, and other space stuff that measures 3.3 billion light years across, according to live science, blanketing about 7% of the known universe. That's quite a big chunk of the known universe. That's as far as we can see with telescopes. The problem is that at that scale, there really shouldn't be any sort of definable clusters throughout the universe, pitting this new discovery against established models of the cosmos, i.e., the Big Bang theory. And
but they don't say it, do they?
They should say.
They never say Big Bang.
Theory is nonsense because
but
modeling.
why do you think? I mean, it's easy to understand why they didn't put the word Big Bang in there, right?
But that's the only established model that exists in terms of mainstream.
Well, no, they didn't put the word Big Bang in there because then the people would associate the problem with the structure found directly with the Big Bang.
That shows you're a critical thinker, that you're able to. A lot of people may not even notice that little bit there, that they don't specifically say Big Bang, but that is the established mainstream orthodox model is the Big Bang theory. And then it says, and setting up yet another dramatic situation in which scientists' best theories about the structure of the cosmos don't line up with real world observations. Exactly. That's what the 59th chapter of my book is. And that's why they keep coming up with new ad hocs to say, oh, how do we explain that? Well, here, on this, well, the cosmological principle, that was an ad hoc. Okay, and then it goes on to the cosmological principle here. The cosmological principle, which serves as the underlying assumption for astronomers' models of the structure and behavior of the universe, i.e. Big Bang theorists, says that when you zoom out far enough, matter in the form of galaxies and clusters and whatnot should be evenly distributed throughout the cosmos. The problem is they keep making, as I say, the size bigger and bigger to try to find this, and no matter how big they go, they don't find the cosmological principle works. Okay, normally when a new study so flagrantly contradicts an established model, and remember this is written in a mainstream they say normally when a study so flagrantly contradicts an established model, it's reasonable to assume that the new study could be a fluke. But according to the research that the University of Central Lancashire scientists presented at a recent conference of the American Astronomical Society, there's only a 0.0003% chance, that's 3 out of 10,000, that they messed up statistically, and that the great arc doesn't really actually exist. I've got a picture of it here. If you go to, you can find, just Google, the giant arc of galaxies is way too big to exist, scientists say. The article is by Dan Robitsky in The Byte magazine.
So what's the name of the structure?
It's giant arc of galaxies, what they are calling it here.
Okay.
That's normally, so that's 3 out of 10,000 chance that they've messed up. I don't think there's a problem with the study. There have been a number of large-scale structures discovered over the years. They're so large, you wonder if they're compatible with the cosmological principle. No, yeah, I don't think they are. I mean, what are these people not very bright? How many structures do they need to discover before they say, well, maybe there's something wrong with the cosmological principle? It's sort of like that idea of changing the facts to fit the theory. Well, we'll just change the definition of the cosmological principle, how big the size has to be. It's not clear what, if any, changes to the cosmological, there the gold things, is what I said, any changes to the cosmological principle would make sense while still being compatible with what we know to be true about the universe. I mean, this is ridiculous. But as Live Science reports, a small community of scientists suggests that gravity somehow operates under different rules at large enough. Oh, now they're going to change the rules of gravity.
Yeah, it's
hold on to this Big Bang theory. There's no limit to how many new ad hocs, how many.
Yeah, but they don't talk. They don't say once. This is like what happens in politics. You know, like the war machine that that we have in the United States. They talk about all kinds of things, but they never mention a specific because they never want to make that how you say, putting those two things together. They don't want the public to understand that what they're talking about. You and I know they're talking about the Big Bang, but then
I didn't even notice that until you pointed it out. I just assumed everybody knew they're talking, but that's good that you point out because you don't realize that that's exactly what they're talking about. I didn't even catch that. What you did, that's good.
Yeah, but I'm sure that's not by accident. What they want to do is they don't want to have that associated. So they could, don't put Big Bang in there. People are going to say the Big Bang's wrong, and we can't have that.
You know why people are adhering so hard to the Big Bang theory? In addition to the fact that the scientists have built careers on it, studied it, become famous for writing books about it, and all that. I think there's a religious aspect to it that. If you get rid of the Big Bang theory, if it falsifies, what are you left with? An infinite universe, a universe that has no beginning. Think of the religious implications of that.
Well, you got to remember, though, too, if I remember correctly, I'm pretty sure that the Pope at some time, a Pope, had said that the Big Bang theory was finally accepted by the Catholic Church. But it was, and that was in the 20th century, so if not the 21st century. So it's the case that they've just adopted it, and then
Interesting though, the creator of it was a Catholic priest, Georges Lefebvre, and he said to people that knew him, "I'm creating this theory to conform with creation in the Bible." That's what he said. That he said, "I want to create something that matches what the Bible says about creation." So I'll call it. I don't know if you call it Big Bang Theory time, but whatever. That's the name that it's a religious theory to say, well, God creates the universe through this Big Bang theory. But the whole point is, if there's no Big Bang, if the universe has what I call there's notfinity, there's no beginning, there's no end, that means there's no creation. If there's no creation, well, where does that leave a role for a creator?
Right. Well, yeah, I think people who I know who are religious, they just think, well, the universe has been there, God's been there forever, the universe has been there forever. And I think that's I don't think it's going to have any kind of conflict there. But I think what's more interesting is that the Catholic Church literally not too long ago buys into the Big Bang, and the Big Bang's wrong. So now what are they going to do? They're going to have
buying into it.
They're going to have to unbuy into it and say, okay, the scientists were wrong.
But there's the thing about papal infallibility too. Like, how can you go back and forth?
Yeah. But we're not going to talk about that part today. But I'm going to bring up the list here, over 60 problems. Now we have them. You had mentioned one of them that was new. Now, what other ones that you have here that are newer that you would say from the clusters or the ribbon or whatever you want to call the big galaxy structure? What else in your book that you said you added that wasn't there before with a?
I was going to read at some point how the Big Bang Theory is defined. Do you want me to do that?
That would be perfect. Yeah, that's fine.
Yeah,
that's actually good.
I've got this in the book too. Like, the Big Bang Theory is this is Wikipedia's definition. Is a cosmological model of the observable universe from the earliest known periods through its subsequent large-scale evolution. The model describes how the universe expanded from a very high density and high temperature state, and offers a comprehensive explanation for a broad range of phenomena, including the abundance of light elements and the cosmic light microwave background, that's called the CMB for initial radiation, and large-scale structures. If the known laws of physics are extrapolated to the highest density regime, the result is a singularity, which is typically associated with the Big Bang. A singularity means going back into, where there's laws of physics breakdown, basically. After its initial expansion, the universe cooled sufficiently to allow the formation of subatomic particles and later simple atoms. Giant clouds of these primordial elements later coalesced through gravity in halos of dark matter, eventually forming the stars and galaxies, the descendants of which are visible today. So that definition is a good representation of how the Big Bang Theory is viewed today.
Yeah, one of the things I always talk about with people who are like at a party, and then I'm bored out of my mind talking about things that at my age, I want to talk about stuff that's interesting, and they get to science, and they say, "Oh yeah, like the Big Bang's wrong." Oh, well, the Big Bang's wrong. I said, okay, when you were in school, you learned about how the solar system was formed, right? Okay, and you learned about stars, how those are born, yeah, and you also learn about how stars are die, yep, and then you hear from Carl Sagan way back that we're all star stuff, because once it explodes, it comes together and it builds another one. Now you tell me, if I'm talking to the person now, if there's a Big Bang, why are we talking about a life cycle of birth and death over and over again? Doesn't sound like a Big Bang to me.
No, this is getting more into. Roger Penrose has come up with this idea of a cyclical Big Bangs, where you get a Big Bang and it goes through its evolution, and then eventually it contracts, and then another one happens. And he thinks that he's found the evidence of in our universe of previous Big Bangs from things that have been left over from it. But that's his idea: is you get a Big Bang, it goes through its life cycle. You get crunch, and then a new one that develops.
Yeah, there's another one called the Brame. Have you ever heard the Brame?
Universe is collide and
Yeah, they're like pieces of paper, and each one's a universe. Forget about the idea that the universe in almost every language should means everything. So you can't like have two everythings, but they say that, and so then they say then it touches that these two like will touch, and that spawns a Big Bang. That was one of the ideas as well. So okay, getting back to some of the bigger structure we talked about. What are some of the other newer ideas that you put in your book about the Big Bang being
I'm
wrong?
just going through the contents right now, and I think mostly I kept the same categories largely, but added updated information and rewrote the sections. But I'm trying to Cosmos is
Okay, here we go. I'm going to bring them up here. So let me go through them. We've got expansion or expansion. Well, let's just go through them here. Age estimate keeps getting lowered. Now, wait a minute. I thought the age estimate keeps getting bigger or higher.
It changes from one year to the next. Sometimes it gets higher, it gets lower, depending on what they need to conform with the observations. But I mean, that's another thing. Sometimes they up it, and other times they lower it. It goes from 13.79 to 30.83, and then others research says, well, maybe it's only 12. I mean, it's all over the place.
What happens when we get our new telescope out there even further and bigger? I mean, I remember I was in 1996, I was at the third annual NPA with John Chappell himself, and I went to the Lowell Observatory in Flagstaff, Arizona. In there was a picture of a deep field, which at the time was very new, where they had taken a picture, taken the Hubble and pointed it at into what was supposedly empty space. And what did they find? Thousands and thousands of well-formed galaxies.
Millions.
Yeah, millions. And then what happened? Yeah, right. And then what happens is now we're going to send another one out there. And when that happens, we have to keep upping the size, the age of the universe, because how can things get out there, be well formed if it's like, let's say it's 20 million light years away, 20 billion light years away? That's longer than the Big Bang. So now what do we do?
Well, you know, the interesting thing about that, because the Big Bang supposedly is 13.8 billion years ago, as I say, that fluctuates, is that what the Big Bang theory predicts is that when you get telescopic images from that far out, the universe should look very young. Galaxies it shouldn't even exist when you go far enough. They're finding galaxies that are like second generation galaxies at 13 billion years ago, which are impossible. In other words, the galaxies are so mature that they second generation. It totally violates the idea that the further you go, well, you're looking further back in time. So I mean, the galaxies took supposedly 1 billion years or a time to even start forming, and yet they're finding fully mature galaxies, which can take maybe another 1 billion years at 13.4 billion light years out. As far as we can see with our telescopes, this should not be.
So it's really double, right? Because if it took 13 billion years to get out there, then you have 13 billion years to get back to you. You have then 26 billion years.
No, if these events happened 13 billion years ago, you're saying the expansion took 13. Oh, I see what you're saying. The expansion to get that far took 13 billion years. And then for the light to reach us. Yeah, but the whole thing is silly, because the prediction is that you should be looking at the early universe. It's like looking back in your life and saying, well, if we look back 60 years ago, we'll see a little tiny baby. We'll see a fetus or something. But instead, they see a full-grown man with gray hair.
Yeah.
It wouldn't make sense. Like, well, how can you be 60 years of age? Because we've gone back in our time machine and we see you 60 years ago and you look exactly the same.
Yeah.
Well, that makes no sense then.
So another thing they talk about is redshift, right? And redshift is another thing you talk in the book, right? And redshift is wrong, meaning what they say redshift is. So what do you say about that in your book?
Let me just bring that up here. I know Glenn Borchart's done tremendous work on explaining this too. It's how you interpret what's going on, basically. It's all interpretation. You can here. We got, let me just bring up what I've got here on that.
Yeah, I think you have it here. Redshift, dark matter, and molecular hydrogen.
Okay. Redshift.
So yeah, I mean the redshift.
Here we got something here. There's a high quality YouTube video, and you're aware of this guy named Halton Art. A video called "Expanding Universe Redshift Myth Debunked" by Halton Art using quasars, in which he speaks about his research on quasars indicating a non-expanding universe. He mentions how the astronomy establishment refused to consider his studies. Nature magazine would not read his paper on quasars. I mean, it's funny when people come up with things that contradict what the established science says. They say, well, it can't be right. When they came up with these photos of quasars showing that they're not billions of years out, light years away, but much closer, maybe a few million or a few 100,000. Oh, well, the established science say, oh, it can't be right. Your photos must not be right because we know that those things are billions of light years.
Oh yeah, here's a person, Oliver here from our chat. If you read what he says, similarly, this is very interesting. I've never thought about this, but it says similarly, our galaxy is rotating at a speed that only permits from 45 to 60 rotations since the Big Bang, which is not long enough for time to achieve its spiral shape. That I've never heard. That is quite good. What do you think about that argument?
That's another good one. Mm-hmm.
So it really fits into the argument of us seeing things that are way, way, way older or would take way, way longer than a Big Bang would take.
Here's something that Glenn Borchardt wrote about a redshift, regarding before I'll get to say the choice between what came first, inflation or Big Bang, is a non sequitur. And he says the assumption led to Einstein's ridiculous particle theory of light, in which a massless photon containing nothing whatsoever travels perpetually through perfectly empty space containing nothing whatsoever. The space is empty and the photon has no mass, for which there's no evidence whatsoever. The resulting misinterpretation of the cosmological redshift is what led to the expanding universe theory. To come up with that cosmogonists, those are people that believe in the creation of the universe, had to violate known laws of physics. Individual particles do not display Doppler effects. That is a property only given to media, which in this case is the ether that regressives have dismissed out of hand. Since Michelson and Morley's misguided experiment, there are many mechanisms that can produce a redshift, which simply is the lengthening of waves as they travel through particulate media. Longer waves have less energy than shorter ones. Only the most naive idealist could believe waves could travel the immense distance so far observed without losing energy. In other words, cosmogonists are expecting us, i.e. Big Bang theorists, are expecting us to believe each wave will achieve perfection in producing the next. This perfection is supposed to show no diminishment for 13.8 billion light years. Wow, another ramification of Einstein's untired light theory. I don't know what to say. Everything that the Big Bang theory says is necessary for it to be valid is blown away. The idea of the cosmological principle, the idea of a cosmic microwave background. I wrote something for the magazine when it was called Science Woke about the cosmic microwave background in regard to the Big Bang. It gets so hilarious. Like, how much proof is needed? I guess it was an infinite amount. Einstein quote when he said, there's only two things that are infinite: human stupidity in the universe, and I'm not too sure about the latter.
Yeah, absolutely, yeah.
One thing that we all agree with Einstein on.
Well, you know what I think, though, too, is back in 1999, I believe it was, I accompanied Dr. Carter Riccarazani, who was also, he was a person that came up with the problems with the special relativity also said said that the Big Bang was not not real. And it was funny because he was invited to speak at the Long Island Astronomy Club, where actually Einstein had stopped by at least once or twice. They have a small observatory there, but the people get together who like astronomy. We were out there one night with all the telescopes looking into the sky. It was a lot of fun. And it was interesting because when we talked to these people, this is 1999, it was funny. The astronomy club members said in the discussion inside the observatory there, that they had explained away all redshift as not being the movement of, coming from the Doppler shift, right. Everything except the movement between galaxies. That's what they said. Now these are astronomy people. These people are in the end of the 20th century, and they're all discussing this as, they all agree with it. And so they all know it's against the Big Bang. And yet what we have is we have a population of people, of critical thinkers, especially astronomers. There's a lot of astronomy people that just say, look, the Big Bang's absurd. We all sort of know it, but it never changes.
Well, sorry to interrupt. You know why? Their careers have been based on it.
Yeah, I mean,
if they're 60, 70 years of age, what are they going to? They've written books about it. They're part of an organization of Big Bang proponents who accept it. You could talk to one of them individually, and he would say, "Of course, it's nonsense, but what do you want me to do?"
yeah, it's
a heretic. I mean.
Yeah, it's really funny because I've heard that before. Who had said that something similar, but it was again with relativity, was Dr. Cynthia Whitney. When she got her PhD at MIT in special relativity, she then went on her first job to apply those equations, which she had to a ring gyroscope, a gyroscope where light goes around. Instead of a mechanical thing, they used light. Well, she applied it and nothing worked. Nothing worked at all. And so she goes back to her professor, who was her professor for her doctoral thesis, and says, Professor, I have now taken my doctoral thesis, which you looked at, you approved. I got my PhD in, and I applied it to the very first application, and it fails. And the professor more or less said, "Yeah, we know." And you think, wait a minute, how can you know? Because that experiment alone you'd have to throw special relativity out. And she goes, well, that changes everything. He says, well, yeah, it would. Yeah. He says, well, we got to do something about it. No, we don't do anything about it. And at that point, she became a dissident or a person, who was outside the mainstream, because, you can't lie about an experiment that's staring you in the face with a PhD on a set of equations that have to be applied, but when applied, fail. And yet, again, they don't want to say anything. Another story in the same mode was Dr. Karazani, when he was trying to get some of experiments done to show special relativity wrong at the Stanford. He did one at the Stanford Linear Accelerator, but he was also talking to Alvarez, who was one of the Nobel Prize winners in physics. And he showed his work and everything, and Alvarez was in his 80s. And Alvarez said to Karazani, says, well, sir, you may be right, but I'm too old to fight. So, I mean, you have the whole thing of why are people clinging? I mean, people aren't really making money off of this. It's different. Whereas relativity, you have the University of Israel, who was making $10 to $12 million a year because they had the rights to Einstein's theory and image, because he had willed it to them before he died. Well, that ran out, but now they got their Facebook page, which has 20 million viewers, and so they're still making money off of it. And so people are very interested in keeping Einstein as a genius because they're making money off him. But what's happening with the Big Bang? I'm just trying to figure out what...
Let me just say something in there. You're familiar with Leo Tolstoy?
Yeah, sure.
one of the greatest writers of some people with War and Peace and books he wrote, considered maybe the best writer ever. Let me just read you a quote first, a preamble first. From the evidence in this chapter, BBT is invalid because it is fundamentally without any basis in observation. It violates several of the 10 assumptions of science, that's Burckhardt's, which for any other theory would make it non-scientific. The primary argument of its supporters is CMB and redshift. This chapter provided several alternative explanations for both phenomena that do not require a Big Bang expansion model. Furthermore, the CMB origin theory and cosmological redshift are wholly dependent on two discredited concepts, an impossible inflation theory and the cosmological principle, whose supporters continually change their story when observations falsify, making it non-falsifiable. How do you falsify something if they keep changing the theory? If BBT was just now being proposed as a new model, no competent scientists would take it seriously. I'll get into the Tolstoy thing. And I believe that one of the biggest reasons that BBT is so entrenched among astronomers is best explained in a quote from Leo Tolstoy, one of the greatest writers whose books had a profound influence on the world, including Gandhi and Martin Luther King. Although he was speaking generally, what he said is applicable to many of BBT's proponents. Here's what he wrote. I know that most men, including those at ease with problems of the highest complexity, can seldom accept even the simplest and most obvious truth if it be such as would oblige them to admit the falsity of conclusions which they have delighted in explaining to colleagues, which they have proudly taught to others, and which they have woven thread by thread into the fabric of their lives. And this is written over 100 years ago in the 1800s. I mean, he could be talking about the Big Bang Theory. And imagine if he was alive today saying this, about the Big Bang, would they say, oh, he's just an old man, forget what he says.
Yeah.
This guy was a smart man. He inspired Mohandas Gandhi. He inspired Dr. Martin Luther King. That's where they got their ideas from. Great philosopher, great writer. And he says, you know, this is why people stick to discarded ideas. Their career, everything, their identity is dependent on that. You're taking someone's identity. If you say the Big Bang Theory doesn't work, then, well, that's my identity. And that's one of the reasons I mentioned in my book, I don't have any emotional involvement with any theory, including any theory I'm supporting in the book. I just present evidence. If you show me evidence that refutes gravity theory that I present in the book, fine. Then it's not personal to me. I'll say, great, wonderful. You've alleviated me of a false notion. Whereas other people, I think, scientists say, oh, no, I have to defend that theory because it's their identity.
Well, no, I mean, I talked about that in one of my rants on ether, because I know one of the things that Glenn Borchert says, and even in your book, it says that, you can't have this idea that waves have to be through a medium. Of course they don't. I'm going to be writing a paper for a conference. I mean, if waves were the only way to make waves were in a medium, then we have to throw out all of we can't be on this conference, on this video conference right now. Why? Because we're sending waves of light, waves of light in digital format. They are moving. And if you look at our particle model my father came up with, is that light can be described as moving particles, but one of the things I talk with him about is the word frequency. The idea, if you take a photon, you can't get a frequency out of one thing. Frequency, by definition, linguistically means it has to come along more than once. So the idea that one particle could carry frequency, you can't do it. But if you have waves of particles, you can. Now, that's what my father and I make our model different from all the ether models. And so one of the things is that myself, I am not an etherist, but it is a valid model for light. But it's not the only valid model. And what's interesting to me is that as much as I read Borchert, as much as I read Jeff Yee's model, you have it in your book, Borchert's work, I can see that as a valid model. But there is an alternative to that. And one of the things is that you have the right attitude, it's very, very hard. And what you had described as not wanting to pull out and see that, I will tell you that 95% of people who believe in ether are in that boat. Because as soon as we show them a new model that can do even better than ether, which is waves of particles, not just one, waves of them, all traveling together through space, and yeah, they're like, we believe Borchert's the same, my father and I believe the same. We think that anything traveling through space, it's not going to be forever without any consequence. It's not. So our model suffers the same thing of a redshift as any other but people's model. But people in the dissonant world, George, are stuck in their own models. They cannot pull themselves out to even acknowledge, for instance, my father's model for light is a totally valid model and doesn't have the problem of a photon. Photons are massless. That's stupid. Photons can't, but one particle can't transmit frequency. It's stupid. But what I'm saying to you, George, is that I see the same stubbornness of investment in a theory. For you to say that you're not invested emotionally is quite remarkable, because most people, even dissidents, are emotionally attached, especially to ether.
You know, when I was young, in my teens and early 20s, I was an adherent of relativity before I started questioning, looking into it deeply. Quantum mechanics, I mean, this was science. I mean, this is what I grew up with. 18, 19, 20, I mean, that was revealed truth. But then when I started looking at evidence against it, I mean, it didn't bother me emotionally. Oh my God, everything I've been studying, all the dozens of books I've read on it, all that knowledge I was gaining on it. Well, I guess that was a waste of time. No, wonderful. If there's problems with it, then I don't need to carry it with me. You know, I started to take up Bohm's view too. David Bohm, you're familiar with him.
Yeah.
And his idea was, I have a chapter on him, which I call Bohm and Hiley's approach. His idea was, we will never, and this is where he had a disagreement with Einstein. He said, we will never have a ultimate model of the universe. Einstein's idea was eventually physicists are going to, and astronomers, we're all going to figure out we'll have a model and this is it. And he said, no, we'll always find something that whatever model we have is will get subsumed into a larger model. That this process will go on endlessly. So in other words, why adhere to a model that eventually is going to be replaced by a larger model that just, it's the same thing with quantum mechanics now. You got people in that field saying, including, I believe, Roger Penrose, that this is going to be that quantum mechanics will become part of a larger model. And the same thing, like Newtonian physics isn't wrong, it's not complete. You know, and when we say that, oh no, only this model is complete, no, it's, you know, on that level, I'm 100% agreeing with one. We're always going to say, oh, well, that was just, same thing with the universe. We used to think the entire universe was the Milky Way. You go back further, but up until about 100 years ago, that was the universe, the Milky Way. And then we realized, oh my God, those little things out there, there are other galaxies, all the others. And now what they're finding is the universe itself is maybe 10 times larger, even the known universe, than what we were saying a few years ago. Because they're finding far more galaxies than they ever thought could be possible. It's, you know, it's observable universe. We have no idea how big the universe is outside of it. In my contention, is not finity. There is no end. These objects, stars, galaxies, super galaxies, go on. Why would it? You don't come to a brick wall that says "end of universe," cannot pass this point.
Well, one of the things that Borchert, that, you know, again, our model stands on the shoulders of Borchert. I mean, tremendously. Without Borchert's work, our particle model wouldn't exist. Well, one of the things is that if you have a universe and there was an edge to it, right? You would get to an edge. What is keeping it together? Right? I mean, you have this, if you believe in infinity, I mean, it's like the idea that the neutrino exists, which I think is a joke, because a neutrino, it's a long story, but neutrinos were invented to save special relativity. We know, right. And then what happens is, Well, according to that, everything in particle physics says everything turns into a neutrino, and will eventually the universe will be just a sea of neutrinos. But if you have an edge to it, how do you things that this whole thing of keeping things together?
And I address those kind of issues in the book, and the most radical conclusion I've come up with in the book on this whole idea of is there a finite universe? If the universe is not finite, which they call notfinity, you know what the conclusion I come to on that? Since an object is always a finite thing, right? Whether you're talking about a house or a boat or a planet, you define things by their boundaries. If there is no boundary, then there is no object that you can label as, quote, the universe, because there's no final object. Right. What this means then is that, in a sense, that's why I came up with the title Notfinity Process. There is no universe. There are only these things that you call microcosms and objects and galaxies and supergalactic structures and larger and atoms. But there's no final thing that you say, here is the universe. Because if there was, that means there's nothing beyond it, which is absurd. You get a wall, nothing. There's no space beyond it, no matter, no. And I also show that matter has to exist, because it would be impossible for it not to exist, because if matter doesn't exist, then that means there's nothingness. And I said, well, you can't have nothingness, because if nothingness exists, it must be something, because anything that exists is something. So you can't. I go into it in detail in the book. Like the very concept is illogical to have nothing. He said, well, nothing exists. There is a state of nothingness. Really? Well, then it must be something. No, yeah. I'm saying that objects go on forever. There is no end to it. So I don't talk about an infinite universe. I say there's a notfinity process, and it's matter in motion. And you're the one that actually changed the title of the book for me. The first one was Microcosms in Motion. And then I realized, well, only scientists or people in the field maybe know what I'm talking about by microcosms. Everybody knows the word matter. And I thought it was a mistake when you sent that title back as Matter in Motion, but it's actually very smart.
Well, yeah, well,
matter in motion is more accessible than microcosms in motion. So remember, when you look at the book, look for the title with Matter in Motion. The other one, if you click on it, it'll say not available or.
Sure, yeah. But a couple of things. One, you're right about the universe. You're not going to find the edge because it's going to keep going. Yeah. For us to say there is one, I think the only difference is, if I were to look at it linguistically, because that's what I do for the last 30 years, is trying to figure out what people mean by words, right? I got a master in linguistics. I work with computers, try to understand it. One of the things is for me, is universe is meant to mean everything, even if it's infinite. It's meant to mean, you can't really do it. You can't put it all together, is what you're saying. And that's very true. But we do need a word for that.
Well, that's why I keep, to me, the problem with the word infinite is it's become a concept, and all concepts are finite. So I'm trying to say, well, I know a person can create the word notfinity into a concept too, but at least there's a reminder in that word that I'm not saying what is there. I'm just saying I know whatever is there is not finite. I'm not attempting to create a concept, although I know it. Words inevitably are all concepts, and they're finite. So notfinity too can be a concept that defeats the first. I'm just trying to say, no, let's not say what is it. All we know is it's not finite, and we know it's process, and we know there's matter in motion. But that's the only one of the.
Well, I love the word. I mean, it plays. I think it's an extremely fascinating word, what it means, where it came from. I think it's great. I want to get back to I want to get back to this idea of letting go of things. One of the things that when people ask me, I'm 61 now, if I were to look at what I consider to be successes in my life, what was some of the characteristics that I think I have that has made me successful, even to get to where we have our particle model, my father and I, in the book. I mean, it's successful because I listen to other people. I will see a better idea. For instance, when I met Dr. Carazani, he came to me and he put a pile of papers on my desk in the early 1990s. It says, hey, I showed special relativity wrong. I came up with new equations. I didn't think to myself, relativity's right. How could you say that? I go, oh, that's interesting. Let me read it. Somebody comes up with a new model of the universe or a new book on the way they think the universe works. I always look at that as, oh, this is cool. I wonder what they're going to say.
Right.
Now that kind of attitude, I thought was something all scientists need to have. But the truth is, even the really good critical thinkers I know have a hard time of letting go of anything. I have programmed in my life so many computer programs where I've gone along and I've literally spent weeks on it, sometimes months. Then I come up to a point where I see a much better solution. And I'll drop it and start over. Now, that kind of person is really hard because I've invested, 3 months of my time. I have to go to my boss and say, I've just spent 3 months of my time coding this computer code, but now there's a much better way to do it. And I think what you say when you say, I see something, oh, that's interesting, I see that's a better idea, or I was wrong on something, you just go, okay. That's the way I look at it.
Right.
But I really don't see that even in the CMPS. I don't see that almost anywhere.
No, I understand what you're saying. No, it is because it's attached to it becomes someone's identity, and the longer someone is with a particular model, the more it becomes their identity, and so it is a problem. Yeah.
Yeah, and I mean, I think that in you, that is extremely rare. That is very rare that you are not, like you said, oh, I'm not, I have no problem of this is right or this is wrong or I've thought about this for a while. Most people, it doesn't happen. I mean, I just literally sometimes talk about, for instance, my father's model of light with the ether. And when I talk with etherists, they look at me as if I'm speaking Chinese. I mean, they don't even think it's such an easy idea. I said, look, we send digital information across to our phones. We send them to videos. We send data. And you get that, right? Yeah. Well, that's what light is. And then you look at them. No, light's ether. They bounce back into their ether world. And they then say they don't even give themselves a chance to see, for instance, what my father had come up with. And again, I'm not here because it's our model, it's our book. This is a really interesting psychological thing that you're talking about, that you had, Tolstoy, right? You read the quote from Tolstoy from 100 years ago.
Oh,
yeah.
Yeah.
I've already said to people, and I've said this many times, my father and I are going to present our model. It's going to, if you're an etherist, 9 out of 10 of you, probably more, it's going to fall into deaf ears. It's almost like they're not going to hear it. And I'm thinking to myself, I know that because I've talked to people and that's what happens. Why is it we get even in that's a problem? Because if I always tell people, one of the things I've told people from my movie, I said, look, you've got a great idea. I mean, for instance, Jeff Yee has a great idea. He has this idea about how to put a nucleus together and how electrons then will get into their orbits, right?
Right.
Very good model. And I'm thinking to myself, we took part of that into our model because we can describe what he's talking about even a little bit better. Not necessarily the exact details, but we can give physicality to what he's talking about. Now, I took a part of that. We took Infinity from Borkert, who is an etherist, but we have a different model. I said, if you have really great ideas, someone's going to come along, see the nucleus of something that you've made, put it together with something else and make a better model while you are in something that you are like this on. And I just see that. I don't know how to communicate that to people in our group, to say, open your mind, folks. I'm seriously, when I get a book from somebody, and my father and I have worked 6 years on this model, I get a book and I think, maybe this guy's got it. And what we are talked about is throw it out. I think that in my head, right?
I think what's important is the work you do, or anyone does, is important regardless of whether it turns out to be the final model. It's just the work that science progresses. Each person within science is making a contribution. maybe the idea they come up with or their theory is wrong, but their work is valid because they're pursuing, if they're using the scientific method, if they're following all the established scientific ways of doing science, that is what's important. That's how science progresses. Not by saying, well, here's the ultimate theory. And even if 5% of what someone comes up with in a model gets used in another model, that is enormous.
It is.
Okay.
I know.
But it's not. We don't need 100% of a person's model to be.
Of course.
Back in the I've read a quote like in the 1920s, where after radio got invented, scientists were saying, well, we don't need any more research on technology. Science has reached a dead end. We've invented everything that could ever possibly be invented. We don't need that research on. That's what they thought in 1920. Look at all the inventions since 1920. Television, cell phone, it goes endless. And yet we thought in 1920, we've reached a dead end. There's no more science to be invented. We've got all the theories. We've got all the inventions. We can just shut it. That's not an exact quote, but I mean, holy smokes. We didn't even start getting high tech until the 1960s or 70s.
Yeah, one of the things when we had our NPA conferences, when I was really heavily involved and actually was really pretty much organizing and running them in general, one of the things we had was sessions that were breakout sessions. One of the biggest problems you have when you have a conference is my work is the most important. Everyone should know about it. And so I should be in the main room and talk to everybody and they all need to listen to me. Then what we would have is we'd have a conference with so many people that we didn't have enough time to do everybody speak in the main room. Everybody would get 5 minutes. So what did we do? We have a morning session where everybody was there, and then the afternoon sessions, we have breakout sessions. One of the things I always told people to do was go to one of the talks that you have least interest in. Right. Completely least interest. Do at least me one favor during this conference. Go, just say, I don't want to go to that. I'm not interested. Go to that talk. Because what you will find is it will make something, new connections in your brain, in your neuron system, in your brain, that you would have never gotten going to all the ones that you like. Right. Because it's going to give you a completely different perspective of something, and it may not contribute anything directly to your work or your model, but it will trigger new directions that you would have never thought about. Okay. And it was, and what I remember is a couple of people actually did listen to that, and they came up to me and says, "You're so right. I mean, I just never listened to Don Bradell's knots and his how he ties knots and how he makes all these amazing things about structure." And I was blown away. I goes, "There you go. You didn't listen to it. Is the universe made up of knots like he says? No, but the system and the thing that he had thought decades on has come to some conclusions that will hit and stick with you and will contribute, just like you said. Like I said, our book stands on Lionel Denis, Borkert, Lesage, Newton, all of these people, now at Jeff Yee, Kirkendall, all these people, and we took pieces. We didn't take the whole thing. I didn't take the infinite universe theory from Borkert. I took his infinity. I took his there are no partless parts. We took all these things that are super important.
And no partless parts means every particle has parts. You don't get an absolute ultimate particle that has that doesn't contain anything.
Right. Right. Yeah, but I do want to commend you, because I do know you're a person like that, and it is just really hard to find a person who is, like I said, if you're an etherist, you're going to shut your brain to whatever alternative there is to ether, even if it's a valid one. If you're a different theory, if you're a person of Big Bang, you're going to shut your ears to anything that would say infinite universe forever. It's just evolving. People say, if there's no Big Bang, what's happening? Well, the universe has been here forever. The life cycle we see that stars go through, they go through that probably forever, at least for a way, 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 way longer time than what we say the universe, trillions, quadrillions of years. I don't know, but that's, I think that's really, really important if people can. That's why I like to do this and have people on with totally different ideas and theories, because it's going to make something click. I mean, I've watched Jeff Yee for years, and when he put the simulation of putting the nucleus together from what he calls the quarks or whatever, and then all of a sudden the electrons are going in the right places, I'm thinking, this is amazing, because he's really doing it. Yeah, he has equations, he doesn't have a real thing for it, but that is an amazing thing.
I'm just reading some of the comments up here, and they're saying that George should get the most animated presenter award.
The what? Which one is that?
One of the comments is George should get the most CNPS most animated presenter award, and even with sound muted, George's appearance would be good.
Oh yeah. Oh, this is in the private chat, so people that don't see that. Yeah.
Oh, one of the things I'd like to mention is at the back of this book, I think it's 30 pages of a bibliography, which means if I'm going to critique the Big Bang Theory or relativity or any of these things, I want to be thoroughly immersed in what the theory is about. So it took me, I think, 30 pages just to list all these books that I've sourced.
Right.
And I'm being open to each of these as I'm reading them, and then at the same time saying, well, what are the problems with these? And you need to know what the model is that you're critiquing. You just say, well, it doesn't. Here's my model. No, you've got to know it better than the people that are writing these.
Of course.
Because you're looking for what is it? What is their theory? Is there problems with it? Are there?
Right.
And so you can debate them, and if necessary, and say, well, I understand you. Have you considered these things? But I think one of the big problems is trying to change the present model is people have to have good social skills when they're talking to someone that has the Big Bang model, not to insult them for having it, not to make them feel under attack, but to reach a common ground where it's not personal. And believe me, I'm aware of scientists who do make it personal. Top level science, they argue with each other. This is not, you've got to respect the other person and say, okay, they've got a different theory than mine. It doesn't mean that you are enemies with them. You're all scientists. They have reasons for adhering to it. If you want to change their view, you have to respect them and show them, well, have you considered this? And I respect all the scientists, the ones that believe in the Copenhagen interpretation, which I find tremendous problems with, in quantum physics. The ones, they're all scientists that are, on some levels, they want to find the truth. And they maybe have different theories, but you got to respect. There has to be a high level of
that is, I love that observation. That's why I always like talking with you. It really is true, and it's funny because I actually do that when I bring in a person who's got a theory that's very different from everybody else's. Right? I bring them on this show, or on this channel. I make sure I have this empathy inside of me that thinks this person spent decades working on this. And I want to make sure they feel comfortable. They feel like their work is worth something. I try to, when they themselves are not good communicators. Many people who are very brilliant minds are like, I even say myself, are artistic in some way. And I don't mean that in a bad way. And sometimes they're not able to communicate well. They don't know how to say it. They don't know. I had to learn how to speak like I'm speaking now, because my problem is my head always thinks way faster than my mouth. So I'll start a sentence and finish another one. And what I've had to learn is keep talking, stay on that focus. But how do you make a person feel comfortable when you talk with them? So if a person comes up and they say, oh, this and this and this, and this is so well, and I love it. I said, it's interesting because, and then I'll go off and talk about something else that maybe go against Einstein, for instance. It's funny because a friend of mine, she got her PhD from it. And when she applied it to this, it failed, and she didn't know what to do. And then the person starts to open up and starts to, but having a couple abilities. This is what you brought up. One, can they communicate what they're even talking about? Right. Karazani handed me a stack of papers like this, on a desk. And then when you he starts explaining his theory, he talks in mathematics. No one understands it. Right. So it took me 3 years to explain Karazani's theory. Basically, what he says is mathematically he found that two frame systems, two coordinate systems, mathematically are redundant. You can only have one. The two is artificial, and if you base a theory on two of them, you are going to get a wrong answer. And then it took me that 3 years to be able to say that to an average person. Right. You know, and that there's only one three-dimensional space. The idea that you've got one over here, this inertial frame, and this inertial frame, and then you're going to start doing mathematics, you're going to end up with crazy things like time changes, mass increases, etc. You know, but Karazani came to me because he knew he couldn't communicate his idea to the world. And what you are saying is the same thing as, can a person, when a person is talking about that, can you make them feel comfortable about getting and talking about these things that may go against something that they already know? Can you be a communicator? And very few people can do that, really.
You know, in my other profession is in counseling. I work with people with autism, and they have helped me tremendously because many of them have trouble with abstractions. So I've had to learn over the last 30 years how to present things as concretely as possible, as concisely as possible. And that's helped me in writing these books, because there's not a wasted word in that book. In 408 pages, if I had written like other people where they say in other words, or in my opinion, all those words are totally not needed. I just come to the point each time. But I think that came from my working with autistic people, and as you know, many brilliant physicists have been people with autism. Some of the best, where they have very limited social skills, but they have tremendous theories they've come up with. Some of the best. And no, I appreciate that the opportunity I've had to work with people with autism, because they have helped me be a better communicator in terms of getting to the basis of what I want to say in as few words as possible. And you remember the talk I gave in 2017 where I was talking about consciousness and a bowl of vegetables? You remember that, where I was saying, you all these vegetables, and then someone comes along and says, wow, how did those vegetables produce a salad? And I say, no, it didn't. That's just what we call them, chopped up vegetables. You know, it's all about how we use abstraction, whether Big Bang Theory, relative, everything comes down to what abstractions are valid and what are not. And many abstractions are not valid. So why are we carrying them?
Yeah. Okay, so we are at 20 till, which is a time I usually give people opportunity. If you are in the chat, you can go ahead and put a question there. I've been putting up a few things, but if you have a question or comment that you want specifically addressed by George, you can by putting question colon or comment colon.
You want me to read this one? How does George treat the mother of all theories, that space and time are continuous?
Oh, wait a minute. Is this? Let me see if this is. No, this is in the private chat. Okay, so let me bring this up and bring that to the public chat. Okay, so go ahead. You want to answer that one? We can. Go ahead.
In my book, where I talk about time, I'm looking at it more as Burckhardt does, where time is motion. In other words, I've also had to invent Nadal as the way of measuring that motion. But so I've got two words. You got Nadal for measurement of motion, and motion, which is you look at the Earth spinning on its axis. And we say, well, a day has passed. And I say, no, a day hasn't passed. What we're saying is one revolution of the Earth, on its axis, we call that a day. So I'm saying that time is really just motion. It's another word for motion. And the measurement of that motion is, I've invented the word Nadal to measure it. Once around the Earth around the sun doesn't take a year. We call the Earth going around the sun. We say that's a year. It's just historically we've used that term. So so time itself, motion. If you're saying time is motion, yes, motion goes on, has no beginning and has no end. It goes forever. That's why I've got the term matter and motion. And the other part of the question was space and How does matter of all theories get space and time? Well, to me, there's no end to space. You can't have as I said earlier, you can't have a wall that says this is the end of all space. So yes, it goes forever. It's not finite. And so time is just, if there was no motion, then there'd be no time, but you can't end motion. Even when they try to freeze things down to minus 0.0, or not minus, so 0.03 Kelvin or something, there's still internal motion going on. And one of my clients I was recently pointing out you can't get below zero, because if you do, you got to think of it as a graph. You've got on this side, temperature's getting hotter and hotter. On this side, temperature's getting colder and colder. Up at the top, you reach absolute zero. If you went beyond that, according to the scientific research I read, you get into a state of infinite heat, because you're getting to the other side where things keep getting hotter. So the whole thing is absurd that you can get below absolute zero, or because then you're not infinite heat, and you can't get to absolute zero, which means there's always motion.
Right. And this is very much from Borkert. Now I'm going to bring up some people in the green room. Bring up your hands. I do see a person there. James Keane there. I'll bring you up like this. How are you? You're on mute there. Can you unmute yourself? There we go.
Hello.
Hi,
thank you, George, for a wonderful presentation. Actually, you didn't answer my question. That was my question about space and time. Are they continuous? You mentioned a definition of time. You mentioned that space is very expansive. I mean, very great and infinite or whatever.
Yeah.
But you didn't answer the question. Are they continuous, or are they discrete and quantized?
Yeah, no, quantized. I see space as quantized, and I mentioned that in my book.
I've got you on board, man. That's fantastic.
And I've got an interesting theory too. In terms of if you're aware of Barbour's theory, Julian Barbour on time, I've communicated with him through email. I've got this idea that motion is something that is a brain's interpretation of what's happening. Sort of like when you watch a film, there's no actual motion in those 30 frames per second. It's just our brain is interpreting the change in position. When you're watching things in the world, there's constant change in position. That to me is what's going on. The universe is constantly reorganizing into new positions, and our brain interprets that as motion. It is a difficult concept to get across.
Okay, well, but back to the physics.
You watch a film.
I'm very happy to hear. Back to the physics, George. I'm very happy to hear that you do agree with the idea that this mother of all theories, which is basically the basis for child theories of special relativity, general relativity, the mathematical treatment of the standard model, all of those and more, quantum electrodynamics, quantum chromodynamics, all of it. This one theory is at the pinnacle, or is the mother of all of those child theories. So I'm very happy to hear that you accept that space and time are quantized.
Yeah.
You talk about time as being motion. Well, that would mean that motion is also quantized.
And
thank you. I'm very happy to hear that. Welcome aboard.
When they talk about the Planck length, I do not believe that the Planck length is the ultimate smallest length. I think it's quantized infinitely small. I don't think you get down to a Planck length and say that's the final size. I think you get almost a new universe of
well, being quantized infinitely small may be a meaningless statement. I'll just throw that in. I don't want to monopolize the time, perhaps, for other people.
But I'm glad
thank you for a wonderful presentation, sir.
Well, I'm glad that you called, and it's nice meeting you, James. Thank you.
Okay. Somebody else in the green room want to come up and make a comment? Okay. Hello, Ian. How are you?
Oh, Ian.
Very well, thank you, David and George. A comment, perhaps, and then a question. The comment I'd like to make in regard to Tolstoy's quotation and so on. That's very true. I know this myself, but I don't think that anybody is willing to admit this bias, which indeed is prevalent. I think all people, academics or ordinary people, would say, "Oh, I'm totally open, and if there's any new evidence, I will change my mind." And this is one of my fundamental objections to orthodox physics, that it's hypocritical. You have top academics and professors who actually would say that. I'm sure they would say that, but they're not displaying it in their actual actions. No. I dare say that even Cynthia Whitney's professor would probably say, "Oh, I'm totally open to any new evidence. And with regard to this little evidence, with regard to the Sagnac effect or something, it's a little problem, but we'd have to deal with it at some time. But I'm totally open." Now, my question, George, was basically this. I was a little surprised that you appeared to be dismissing the cosmological principle, because, if one takes the universe not to be finite, I'm wondering what the reason would be for any sort of inhomogeneity or lack of isotropy. We found that we've had to go out to greater distances. We found that maybe locally that isn't true, and maybe with this crescent of galaxies or whatever you referred to earlier, maybe one has to go to that. So I'm not quite sure why that should be so, or if I interpret you correctly.
Well, the thing about the Great Arc, which is occupying 7% of the known universe, it shouldn't be there according to the Big Bang Theory, because of violates the homogeneity. It's way, way too big. So now they're going to have to say, well, the new scale we have to look at is beyond just the observable universe or something. But to me, when you have to constantly increase the scale of to determine whether the cosmological principle is going to apply, where's the limit? If it turns out that, okay, now we can somehow theoretically go beyond the observable universe and find, well, it's still, where do you draw the line?
Well, if the cosmological principle does not hold, what would be your explanation for the lack of compliance with it, for the inhomogeneity of the universe?
Because I don't think there was a beginning to the universe. And I think it's always existed, if you call it the universe, or this Notfinity process. There is no beginning to it. So why would there need to be homogeneity? It's just, it is what it is.
Well, it depends where the onus of proof is. I would say that it probably is infinite in time and dimension, but I would subscribe to a general. I would see no reason why it shouldn't be on a very large scale homogeneous. Although you say we're expanding that scale, I don't see the reason.
But they haven't found any proof of that yet. And every time that they say, well, on this, it's always on a larger scale. They keep coming up with saying, well, it's eventually homogeneous. But we found no proof of homogeneity. So until we can find some evidence of it, why do we say it's homogeneous if there's no evidence? The reason that Big Bang theorists say homogeneous is because it fits the Big Bang theory. If we were trying to support a Big Bang theory, we wouldn't need to say the cosmological principles there. The cosmological principle is there to support the Big Bang theory. If you don't have a Big Bang theory, you don't need that. But there's no evidence of the cosmological principle. It's just that, well, it must be based on the theory of the Big Bang. So,
well, I don't want to monopolize. I better stop now, David. But
no, we're good. We're good.
It's not solely to do with the Big Bang, surely, because I'm certainly a person who's totally with you. I'm against the idea of the Big Bang. I think there's no evidence for it. But philosophically, I tend to accept a cosmological principle because I don't see any reason otherwise. With regard to the evidence, I'm not sure. I think the jury is still out, and I think we need to look at that a bit more.
Yeah.
But one thing.
Thank you for sharing it.
Yeah, one thing I would say to you, Ian, that I would perhaps give you a plausible idea of why it may not be homogeneous from what we see, is that if you subscribe, and I do, to Borchert's infinite universe, the way there are no parts that are partless, But you have to also go all the way up, sort of turtles all the way down, turtles all the way up. Now, if there are bigger and bigger and bigger and let's just make the stupid thing like I heard when in the 60s when I was a kid, and there was a hippie movement says, oh, the solar system is just an atom of a chair of a giant. Now, if it's the case that all of these things that we see, galaxies are sort of like particles or masses that are things that we can see, a group of stuff, that those things make up bigger structures that have an organization to them that is not going to produce a homogeneity, that is going to produce things that are just like what we see. We don't see a homogeneous world around us. We walk through air and there's a tree over there, and it depends on your focus. But I would say that what we see at a very long distance, very large structures, the idea that we're going to see homogeneity, in my opinion, if I believe that structures never get small, we don't find the biggest structure, that is, galaxies are it, that there are no superstructures of this. In fact, if you look at the cover of the Universal Cycle Theory by Pletz and Borchert, on that cover is what they call there it is. And what they are saying, these are structures way bigger than galaxies. So
our known universe, I think. The
red dot, yeah.
So the red dot is our known universe.
So let's say that what we see only today with our telescopes is actually something that is going around an even bigger megastructure. Then I would say that I personally, by that kind of model, see that it couldn't be homogeneous. We're going to find a place that's just not going to be. So in a theoretical sense, I kind of look at it that way. So I think there is a model and a philosophical reason to say that it would not be homogeneous. So I'm not saying that you are right. I'm right and you're wrong. I'm just saying that I can see that as an argument.
See, that is a plausible argument, perhaps philosophically. But as you mentioned, George, that big bangers might want to invoke this. There are other people who might want to invoke the lack of homogeneity to indicate that we're something special in the universe, and we're in a very specific point, and all that sort of thing. So there are various biases that make people believe in certain things.
Yeah,
and I suppose we have to accept that.
Yeah, no, you got some good points.
Okay, all right. Thank you very much, Ian. Always
nice to chat with you.
Yeah, Ian's always got very interesting
books. Here's Steve Bryan's book. Is that up there?
Yeah, well, I've been talking with Steve Bryan for a year, and he is still. We talk very regularly, but he's going to be on this program. I told him we got to talk about your book, so he'll be here sooner, hopefully, than later. But he's waiting for a couple things to happen. He hopes before he would get on.
He's got some. I've been talking to him.
Yeah,
I know what you're talking about. Yeah.
Let's hope. I always root. I don't care who it is.
I predict it's going to be a positive outcome.
Okay, I hope so. Okay, anybody else in the green room who wants to come up? Oh, I do see Jim Marison. Come on up. Let me bring you up in a way. There you go. Go ahead.
Yeah, hi. I just want to emphasize the point about the red shift and its relation to the Big Bang Theory.
I missed that point.
Red shift and the Big Bang Theory.
I just want to emphasize that that is what really started the Big Bang Theory to some extent.
Of course, yeah.
When Hubble found that there was a red shift that corresponded with brightness, and that indicated also distance.
Right.
So there were two interpretations. The tired light was just an unknown physical property of space between galaxies and us that caused the red shift with distance, which nobody had a good physical explanation for, versus the Doppler effect, which was a clearly understood physical mechanism.
Right.
And so that became the dominant idea.
Right.
Yeah.
But
Yeah.
if we just take the tire light interpretation
Absolutely.
as a postulate or hypothesis with an unknown physical mechanism behind it, that one postulate hypothesis eliminates tens, maybe hundreds of ad hoc hypotheses that Big Bang theorists have to invoke to cover their ass.
Okay.
Yeah. Yeah.
Now, I do talk about tired light theory, and in the book, that's I've got a section on there. And Borchardt talks a lot about that too, tired light theory. To me, it's impossible. Anything could be going through trillions of billions of light years and not lose any energy. I mean, everything loses energy when you travel through. It's absurd. So yeah,
well, let's just say we don't know why, but that's it. That's the answer.
Yeah.
Then we don't have to worry about inflation, which has no physical mechanism either, right?
Yeah. No, I have
which is crazy. Yeah, and the Big Bang itself, which has no physical mechanism behind it.
Well, that's a good point. Yeah, I do discuss that. There's very few things that I haven't brought up that in that book that don't apply to it, but that's one of the things also.
And then when you throw in general relativity, which supposedly predicts the Big Bang, then that's how the ball got rolling, really.
Absolutely, yeah.
Okay, well, listen, thank you, Jim. We're going to bring you down again, but thank you so much for your comments. We did, if you haven't seen Jim Marison, we had actually a session with him, so take a look back in our videos. But listen, I want to thank you so much for coming on. People really I enjoy it, whether or not anybody's watching, I still have a great time talking with you. And congratulations on your book again, and congratulations on your work. I'm hoping that you can consider maybe presenting a paper this year, because I think it'd be good. It's just good for your marketing of your book too. Keep that in, So think of a paper that you want to put out there. We're putting together. I will have sometime this month. I'll have a website out there for the fees and all that stuff, how to register and all that. But regardless, I'd love to have you as a part of our.
Just let you know, the last time I presented, that's had almost 3,100 views. The one I gave at UBC.
Yeah.
And still getting requests for how to link to it, which is quite a few, because it's just just a Facebook site. Not many people even know about it, but just word of mouth. The consciousness presentation.
Well, but it's not only that. What we do is I tag them. So when a person does a talk, I tag them with all the things, and so when a person searches on consciousness, that'll come up. So yeah. But no, absolutely. Congratulations on your work. Congratulations on your attitude. If we all had your attitude, science would be way further ahead than it is. This idea where you let go emotionally to these things is something I personally, I pride myself in doing. I think you do it, and it's a really great model for anybody to follow. And plus, again, on your work on consciousness, on your putting together work, against the evidence against the theory of relativity and the Big Bang. So what I want to do is maybe tap you on the shoulder to come back again, and let's make the topic relativity. I know that you talk about it, and a lot of it you use from other people, but still, let's try to put that together. Okay.
I mentioned that when people see the price of the book, keep in mind it's 408 very concise pages. It's like 2 books. That the price is $39.95, 40 lines per page. There's no wasted space, and there's no wasted words. That's why the price is $39.95. Well,
it's a good price. It's a good price.
2 books going at $19.95, and it's good value. And the 30 pages, the amount of research that's gone into there, the rewriting over the last 3.5 years. I was doing 48-hour shifts writing on that book at time.
Right.
Last September, I told you it was done. I did another 9 months of more work since I told you it was finished when you interviewed me.
I know. Well, it's driving me crazy trying to get you to get it published, because every time you said, okay, I think I have about 27 emails saying this is the final version. So.
And that's starting in September, right?
Yeah. Don't remind me. I want to think of it. No, please. It goes to show you that it's an infinite process. That's for sure. Notfinity. Okay. Well, listen. Thank you so much, George. I'm going to take this down, and I recommend everybody getting his book. Information is out there. Just go to Amazon. Look up George Coyne's name. Notfinity Process. Amazing book. Right. And please, if you have read it, leave your comments at Amazon. I'm sure I'm going to do that. It takes me a while to get through the whole book, but I will definitely put in my review for that. So congratulations again.
Well, thank you, David. It's been
All right.
talking to you.
And thank you for getting up so early. For people want to know where he's in Canada, he's in the Vancouver. So it's now getting up to 9 o'clock. You got up at 7, right?
No, I was up at 5.
Well, yeah, you get up at
4 hours sleep last night.
Yeah.
I don't get much sleep, but that's why I thought I've got energy because I had 4 hours sleep last night.
Yeah, that's it.
A lot of sleep for me.
All right. Well, thank you so much, George. Thank you. All right, folks, we're going to be taking this out. We've run over time a little bit, but let's take this out. And remember what I always say, stay critical, stay thinking. I am David D. Hilscher. I am your science therapist trying to get you to the promised land of becoming a critical thinker. Ciao for now.